Hello, my name is S. on a Smiley. Today we will be discussing magnesium ion batteries for Chemical Engineering 361 Engineering Materials class for Professor Fudazi. While you may enjoy the portability and ability to store and expand energy through today's technologies, this wasn't always the case. Batteries were an invention from the 20th century as a portable means of storing and using energy on demand, but in recent years, a challenge faced is meeting the energy demands of newer technologies. As an industrial standard, lithium-ion batteries are facing trouble as sources of lithium are limited, along with recent cases of combustion due to the high heat generated in today's devices such as smartphones. In recent years, magnesium-ion technology is being researched as a means of containing more energy than a standard battery, while magnesium is more readily available than the standard lithium. Despite its difficulties to work with, magnesium-ion batteries are a very promising area for research. You may be asking how a magnesium-ion battery is constructed. The standard magnesium-ion battery is similar to that of a regular battery, with a cathode and anode connected to the electrical current with an electrolyte in between. As quoted by Northwestern 2017, because of the chemical reactions, a buildup of electrons at the anode is caused and creates an electrical difference between the cathode and anode. The electrolyte in between prevents the electrical potential from traveling straight from the cathode and the anode, and the only way to allow that potential to travel is for the cathode and anode to be connected by a wire that runs through the current. This can be illustrated through the usage of a light bulb connecting the cathode and anode together, closing the current and allowing the potential to travel. However, there are still some many issues with this current design. For a magnesium ion structure, the reaction between the magnesium metal anode and the electrolyte causes a plating on the material that can cause instability in the electrolytes. This causes some issues such as reversal magnesium deposition and blocks the diffusion of the magnesium ions, therefore preventing reversible electrochemical dissolution, quoted by Motadi and Misuno 2014. This means that creating a renewable battery source is limited, and a lot of research is needed to use the magnesium ion structure to its full potential. One proposed idea is to use an insertion type anode which would have electrolytes from magnesium ionic salts and polar product solvents, which are solvents with hydrogen atoms bound to oxygen. However, this brings up another issue of slow magnesium insertion and extraction kinetics and trouble with electrodes because of the volume change. Another large issue is that the magnesium bond is extremely difficult to break, which limits its ability to be bonded with different materials. However, there have been newer attempts at using the magnesium base by combining them with different materials to maintain the magnesium properties instead of attempting to break the magnesium bond. Currently, there is research on expanding a titanium disulfide in order to allow the magnesium chloride to be inserted in it, which would allow the magnesium chloride bond to remain unbroken in a process called intercalation, quoted by Schweber 2017. The reason why it is important in expanding the titanium disulfide is because of the largeness of the magnesium chloride, and it would be far too difficult to break the magnesium bond. Therefore, it is much easier to research ways to expand the titanium disulfide to fit the magnesium chloride. The reason why so much research is being put into working with the magnesium ion battery despite its inherent drawbacks is its potential for storage. As technology continues to progress, the availability of materials begins to decrease despite the demands. Because of this, it is important finding materials that are efficient and available. Because of how much magnesium we currently have, creating a source of energy from them will allow us to have abundant resources to work with. The extra charge from the magnesium ion will also allow us to have twice the storage than a lithium ion battery, therefore making the extraneous research worthwhile in developing batteries that can store more and be more readily available. Currently, Honda and Saitama Industrial Technology Center are announcing a new magnesium ion rechargeable battery that is going to be estimated and commercialized by 2018 for smartphones and other small devices, quoted by Morris 2016. Despite the amount of work that goes into it, we find a lot of promise in the magnesium ion battery. We thank you for your time and hope that this video served as an educational tool.